Okay, so we've got this question about a water trough. It's in the shape of a prism, so we've got to think, this is going to be maybe volume. The exam paper has a formula at the front for volume of a prism. So volume equals area of cross section times the length of the prism. So we're likely to be using that just because of the shape and the fact that it's talking about a prism. So let's have a look at the rest of the information. Filling a trough, water leaks at the bottom at a constant rate. 2 hours later the level of the water has fallen by 20 centimetres. Well, if we look at the picture we can see that the 20 centimetre fall is actually in the shape of a cuboid. So we could work out the volume of water and then work out the rate that the water is leaking. So if we look at that cuboid, it's got a height of 20, it's got a width of 30, and it's got a length of 120. So if we work out the volume of that, then it's going to be 20 times 30 times 120. 2 3s are 6, 6 12s are 72. Got 3 multiples of 10, so that means it's going to move up by 1,000. So it's going to be 72,000 cubic centimetres. We were told that it was falling after 2 hours, so the rate of fall is 72,000 divided by 2, so 36,000 cubic centimetres per hour. So that's the rate of the water leaking. So if we now work out the volume of the water that's left in the tank, so that's in the shape of a trapezium cross section, and so that's got a length of 80, length of 120, and the vertical height between them is 40, perpendicular height. So the formula again for volume of a prism is the area of cross section times the length. We need to know the volume of water. So we've got area is a trapezium. Now we need to remember that a trapezium is a half times the sum of the parallel sides times the perpendicular distance between them. So we've got a half of 80 parallel sides, 120 and 80. So 80 plus 120 times the distance between them of 40. And do the brackets, that's 200, half of 200, 100, times 40, 4,000. So that's the area, square centimetres. So the volume of water left is the area, 4,000, times the length of that particular part of the prism, which is 30. So we've got 4,000 times 30, 4 3s are 12, 4 zeros move up 4 places, so 120,000 cubic centimetres. Now the question wanted how many more minutes will the trough take to empty completely. Well, we found earlier that it was falling at a rate of 36,000 cubic centimetres per hour. So if we do 120,000 divided by 36,000, then we find that we get 36,000, let's cancel this down to make it an easier sum, so 60,000 halve each one, 18,000, again halve each one, so 30,000, 9,000, both of those divide by 3, so we've got 10,000 divided by 3,000, and 10,000 divided by 3,000, divide each one of these by 1,000, so we've got 10 thirds, which is 3 1/3 hours. 3 1/3 hours is times that by 60 minutes, 180 plus the 20 extra, so the final answer will be 200 minutes.